You're welcome once again to Adewale Kayode online class, and this is a page where you can see content that can assist you in mathematics, in statistics, and in anything that is related to 21st century ways of engaging and evaluating students. So this time around, we have been working on t-tests, and this is the third video for our t-test. If you look at the second video for our t-test, we suspend the class at a point where we get the variance of the first group and the variance for the second group. So this time around, we want to complete the second part of that video. And if you look at it with what we have got now, we have got our mean that we need, which is 14. We've got our mean for the second sample too, for the second group, which is 10. And we have got our variance for the first sample, which is 7.57. Then the variance for the second group, which is 6.43. Like I said, this video, if you look at the first example we did in the t-test 2, is talking about unequal. Is talking about the unequal sample, and that is why we make use of that formula. And if you look at that video, we have shown you all the formula that are related to both the unequal and equal. This time around, like this example, we can see that is an example for equal population variance. When we look at it now, you see that the sample is the same thing. The sample for the first group is 15, while the sample for the second group is also 15. So the test that assume equal population variance is what we refer to as a pool t-test. And that is why we just have to tell you this. This is for a pool two sample t-test. If you look at, you will see that when we look at the question, from where we started the question, we said an investigation of a workplace related stress among top employee of a company. That is, a psychologist now is recruited 30 line manager to investigate whether the male and female manager differ in their ability to cope with the stress in that workplace. So that means it's a pool of what? Two sample t-test for male and that of what? And that of female. And we have got that. And of course, we have seen the formula like we show you in the second video, the formula where we have got our variance of each group. You can see the formula for the first group, the variance of the first group, and this is the variance of the second group. Now, this time around, now we want to pack everything into the formula. In packing everything into the formula is the easiest thing to do. And that's why I said you don't need to feel panic. And look at the formula again for the sake of those of us that will be needing this for exam. And for those of us that even want to need it to do research. So it's just the sample, the first sample, n minus 1, into the variance of the first sample plus n, that is the samples of the second one. You take one away from that, then the variance of the second group. Then everything divided by the sample size of the first one plus sample size of the second one minus 2, which is also the degree of freedom. Then you multiply everything with 1 over n, that is the samples of the first one, plus 1 over the samples of the second side. So since we have got our mean for the first, we have got our mean, then like I said, this formula to us, I want to give a little bit information about the formula so that we will know the genesis of the formula. This pool variance is postulated by Abimbola in 1995 and Ofo in 2005. So if you want to read more on it, we can see Ofo 2005. And like I said, you know, of course, there is no way we have tried to explain what what t-test is all about. It's a statistical test used to determine whether a difference exists between two group means, and also is stating whether a significant difference exists at a given p value. That is, by the time we get our t calculated now, the calculated value is our p value. So let's go into this. Yes, you know, I've talked about the condition, that the condition is that if you go ahead now and get our p value, that is the calculated value, and this calculated value is greater than the one we check on the table, which we call critical value, we are going to accept the alternative hypothesis. But if it is lesser, if whatever we get here is lesser than what we check on the table, we'll take the null hypothesis. So let's see what the result will look like. So we have got our mean. Our mean now is 14. For the first sample is 14 minus the second sample, which is what? Which is 10. Everything to be divided by. Follow this very well because this is mathematics and we have to follow it one after the other. So when you look at it now, the sample for the first one is 15 minus 1 multiplied by variance of the first one, which we have done already. Like I said, it will be very nice if in exam, after you finish the variance for this first group and the variance of the second group, which you did in the second video, it will be very nice if you can do your table like this, so that it will be easy for you to be picking it from the table into the formula. So the variance for the second one, is 7.57 plus the 15, that is the second sample, minus 1 multiplied by variance of the second one, which is 6.43. Don't forget, after you are done with everything here, then the sample for the first one is 15 plus 15 minus what? Minus 2. It is after that that you had this, which is 1 over 15 plus 1 over what? Over 15. You pack that into the formula. You can see that I'm multiplying this to this now. So let's put everything now. So our t now will be equals to, when you take this away, that will give me 4. And then let me press my calculator at this juncture. You too, you don't need to cram everything like you want to do everything on your own. So that will be 14 multiplied by 7.57 plus 14 multiplied by 6.43. Everything to be divided at 15 plus 15, that is 30. Take 2 away. Of course, that is 28. Then multiply by this will give you everything here, 1 over 15. That will give you 0.066 plus the second one too is 0.066. Okay, don't forget to put your square root because this is going to attract mark. No examining body will overlook that for you. So at this point now, I can now quickly finish up this place. Let me tidy up here now. So 14 multiplied by 7.5. That will give me 105.98 plus 14 multiplied by 6.43. That will give me 90.02. Everything to be divided by 28. Then you multiply the whole things by, when you add 0.066 plus 0.066, that will give us 0.132. That will give us 0.132. I hope that is clear now. So at this point now, I can say 4 over, I need to manage this place now. When you had 105.98 plus 90.02, that will give us exactly 196 to be divided by 28. Then this dot simply means, you know, I put the dot here, it simply means multiplication. So the dot that is here simply means multiplication. So multiply by 0.132. So that will be 4 over. So when you divide this, 28 to be divided by 196. Of course, that will just give us 7. So that will give us, so that's 7 multiplied by 0.132. So when you square this now, so let's square this now. So this is 4 over 7 multiplied by 0.132. 7 multiplied by 0.132. Can we press the calculator for that? Okay, that would give me, that is giving me 0.924. That's giving me 0.924. Let me check if my screen is still covering that side. Okay, it's still covering that side now. So when I find the square root of this now, the square root of 0. Calculator, please. Yeah, okay, I've got that. So so when you square square root of 0.924, that will give me, yeah, so what is that going to give me? So can we quickly get that? So can we get that now? So when you divide that now, so when you find the square root of a minute, I need to get so a minute now, when you want to get this at this level now, so I think we got it up to this level. If we got it up to this level now, so let's continue with this place now. So that means we need to get our square root of 0.924. Okay, so when we get that now, so that will give us square root of that is going to give us 0.961. 0.961. So 0.961. 0.961. Okay, so at this point now, so that means our 4 to be divided by square root of 0.924. Great, so that will give us 0.961. So let's use 4 to divide that now. So 4 to be divided by 0.961, and that will give me 4.16. So our t calculated now is 4.16. So if our t calculated now is what? Let's continue from here. Our t calculated now is 4.16. Now we need to go and get our degree of freedom, so that this time around now we have to go and get our t critical, that is the t value, the t table. So of course the degree of freedom is n, the first sample plus the second sample minus 2. The first sample is 15 plus the second sample, which is what? 15 minus 2. 15 plus 15, that is 30 minus 2, and that is going to give us 28. So that means our degree of freedom is 28. So if you go to your table now, the t distribution table, you go, we will now go and check, let's take our 4-figure table out and check, let's take our 4-figure table and go to t distribution table and check 0.05 under 28. So what is that giving us? Let's check that. What is that giving us? You need to be very careful when you are checking your table, so that we don't check, because at this point, this is where we determine your final answer. Of course, like I said, this degree of freedom is also part of the math. So you just have to show that you are checking it under 28. You are checking it under 28. So once we check that now, your t value now, what is your t value going to give you? what your t-value is giving you. Your t-value, checking it. We have to make sure that the table you are using is right. So can we check? I'm giving you 1 minute to check. Check from the table. So let's check from the table. I want you to also check from the table. Check from the table. Okay. So I'm checking it here, and I want someone to put it in the chat. What you get from your table. So what you get from your table, I'm trying to show you so that you see is that it's the same thing on the table. We want to make sure that we are on the same page because whatever you check on the table will determine. So whatever you check on the table will determine. So I want someone to tell me what you are getting from the table now. Yes, I'm still waiting for your response. I'm waiting. This time around, you are not checking anything again. You are just going to check from the table. You are checking from the table. So in our next video, I'm going to try to see how I will show you what determine to check either from one tail or two tail. So I'm going to show you that. So I'm going to show you that. So let's check it on the table now. I want to make sure you are seeing my table. I want to make sure, can you see the T distribution table? So when you check the T distribution table, you are seeing that I'm checking it under 0.05. Under 0.05. So if I'm taking it down under 0.05, 0.05, 28. So you can see I got 2.048. 2.048. So if I approximate that to two decimal place, that will be 2.05. So that is how I got my T critical, that is the table value now, as 2.05. I got it as 2.05. So if you got it as 2.05 now, so when you compare the two together, let's compare the two results together now. Let's compare the two results together. We have seen what we got from the table now. So the next thing now is to compare and look at the benchmark. What did the rule says? The rule says if the calculated is greater than the table value, you go for the alternative. But if it is less than, you go for the null hypothesis. So at this point now, you are going to accept the alternative hypothesis, because already what you calculate is more than what you check on the table. So you accept the alternative hypothesis. Statistically, we no longer use reject. So it's either you accept. So you accept the alternative hypothesis. So if you want to state that now, I think you've seen that from the question. So let's go back to the question now so that we can get a better interpretation for this. You can get a better interpretation for this. You can get a better interpretation for this. So this time around now, you are going to abandon the null hypothesis and take the alternative word. You are going to take the alternative hypothesis. So what did the null hypothesis that we are rejecting says? It says there is no significant difference in the workplace coping stress of the male and the female managers of that company. So that is what the null hypothesis says. So since the calculated value now is more than the table value, you are going to reject that one and you are taking the alternative hypothesis. So what is the alternative hypothesis? You remember in our second video, we stated the null hypothesis and the alternative hypothesis for this question. So you are going to take the alternative hypothesis, which says there is significant difference. So there is significant difference. So meaning there is significant difference between the what? Between the stress, the coping stress of the male and the female managers of that company. So ladies and gentlemen, we have come to the end of t-test. And if you are just watching this place for the first time, or you are joining this particular place for the first time, take it as a form of encouraging other statisticians to get the right thing by subscribing to this channel. In subscribing to this channel, you get a notification anytime we have a content that can assist you. The second thing you will do is that you can try to like the video. You can also copy the link to this video and share with your colleagues. Like, you know, when I started the video, I said, dear colleagues, dear participant, and dear student. If you are a colleague, that is, you are a researcher that need this kind of a thing, and this video has really helped you, try to copy the video and share with other researchers that are having difficult, especially in the pooled samples of two tests that have equal sample. So you share that with them. Also, if you are a student that needs to write one exam or the other and you come across this video, don't keep it to yourself alone. Copy and make sure you share with others. So that is how far we can go on the t-test. Our next video is going to be video on analysis of variance, that is ANOVA. So once we finish ANOVA, we'll continue with statistical package for social science. How do we use statistical package for social science to run some of these tests of difference? That's the next thing that we are going to do after the analysis of variance. So once again, thank you and God bless you. Keep sharing this video until we got the right tools to test of difference. Thank you.